The next topic is on inequalities. So inequalities, we solve them as we would linear equations, except now we have inequalities. So, for instance, this sign here means it's greater than, this one is less than, this one is greater than or equals to, this one is less than or equals to. This open circle here means that the number is not included, all right, so and you use it on a number line. This closed circle here means the number is included, so these two belong on the number line. And these open brackets here means that the numbers are not included, but if it's a closed bracket, it means the numbers are included. So let's refer to the examples. If, for example, you have x plus 5 is greater than 10, so you would solve it as you would if this was an equal sign. So therefore you would say x is, if it was an equal sign, it would be x is equals to 5, right? But now here you have this inequality, so x is greater than 5. And how do you represent it on the number line? So you draw your number line, and because there isn't an equal sign, so above the number 5 you put on a closed circle and you show the direction of the x value, so x is increasing, x is greater than 5. And you can also write in what we call the set builder notation. So you say you're looking at a set of x values where these x values are greater than 5 and the x values are part of the real numbers. Then the last one is the interval notation, which is where these two brackets come in. So it's an open bracket here because 5 is not included, all right? It's not greater than or equals to 5, it's greater than 5. So you start from 5 and then it goes all the way up to positive infinity. Now with infinity, it's always an open bracket because infinity just goes on and on and on and on. All right. Now, if we move on to example number 2, we have 6x is greater than or equals to 24. Again, we solve for x. We have x is greater than or equals to 4. How do you represent that on a number line? You draw your number line and you put on a closed circle above the number 4 because x is equals to 4 and is also then greater than 4. Set builder notation, again your set is your x values and you're looking at x values that are greater than or equals to 4 and x belongs in the real number system. The interval notation, notice the difference now because there's an equal sign here, then you include, so it's a closed bracket, you include the 4 and it goes all the way up to positive infinity. Then the last one, we have minus 4x is greater than 12. Okay, how would you then have solved for this if it was an equal sign? It would have been minus 4x is equals to 12 and x is equals to minus 3. All right, but because you have an inequality sign here and you're dividing by a negative number, when you divide by a negative number, the sign changes from greater than to smaller than. So x is smaller than minus 3. So every time you divide by a negative number or you multiply by a negative number, the sign changes. So it moves from greater to less than, or if this was less than, then this would be greater than. Okay, so on a number line, how do we then represent that? So I draw my number line. X is less than minus 3, so it's an open circle above the number minus 3 and we're going this way because x is less than, so x is becoming less than, more and more negative. All right, now set builder notation is the same thing. You're looking at your x values, x is less than minus 3 and x is an element of the real numbers. And here now, because x is less than minus 3, you start counting from negative infinity all the way up to the highest value, which is minus 3. And they're both open because there isn't an equal sign here by the minus 3. And from negative infinity as well, we don't include it because it can go on and on and on and on.